Hello and welcome to another wonderful video for you. Today we're going to be graphing systems of inequalities. First, let's talk about number one. We have already learned how to do this in class in a previous lesson. Remember, we talked about dashed lines and solid lines and test points. Go ahead and pause this video right now, and I want you to try number one on your own as a refresher. I said to pause the video. Go ahead and pause it right now. Welcome back. I hope you paused the video and you tried this problem on your own. Let me talk about it a little bit here. So first we notice that we have a less than sign. Less than means we're going to use a dashed line because it doesn't have an or equal to. I also notice that this inequality is in slope-intercept form. So I'm going to plot my 5 on the y-axis first, and I'm going to go up 3 and over 4 because that's my rise over run, or my rate of change. Once I did that, I needed to test a point. It cannot be a point that's on the line. 0, 0 is not on my line, so I substituted it into the original inequality, and then I worked it out, and 0 is less than 5, so yes, my test point worked. My test point's over here in red for you to see. Because that worked, you shade that side of the dashed line. If you need to pause the video and fill this in or fix the problem that you just did, you can do that at this time. Otherwise, I'm going to move on. Okay, let's keep going. You'll notice number 2 here has 2 inequalities. So now we're not going to just do one, we're going to do 2 of them. So let's go ahead and start with our first one. For this one right here, I'm going to do this in blue. Y is greater than 1/3 x minus 4. The first thing I want to do, since it's in slope-intercept form, is plot the y-intercept. From there, I would do the rise over run. Up 1, over 3, up 1, over 3. And you can repeat this pattern to the left also. You'll notice that we do have a greater than, so this is going to be a dashed line, and that's important. There we go. Now the next thing we normally would do, just like we did on the first one, is we would use a test point. So my test point, which I'll do in red, is going to be 0, 0, since 0, 0 does not fall on my dotted line. I'm going to substitute it into the original problem. When I do this, I work it out, and I ask myself, is 0 greater than -4? And yeah, it's definitely greater than -4. So here's my test point. Since this was true, I am going to shade that side of the dotted line. Now, before you shade, I'm doing this in highlighter. If you do this, do it in pencil, because in a second, well, not a second, in about a minute or so, we're going to be erasing things. So you can just watch it and then fill it in at the end, or you can use pencil and you can erase at the end. It's totally up to you. So let's go on to the next one here. So on this one, I'm going to go ahead and do the same thing, slope-intercept form. So I plot my 3, and I go down 2 over 1, down 2 over 1. And like a really good student, I'm going to go all the way across my graph and make my teacher really happy, right? Okay, right here, solid. And if you want to write this here, dashed, you can, but you should probably already know that from the lesson we had in class previously. So this is going to be a nice solid line. How beautiful is that right there? Next thing we're going to do is the test point again. So test point, again, it's in red on my graph, so I'll keep it red right here for you to kind of match it. Substitute in your 0. Is 0 less than or equal to -2 times 0 plus 3? Well, I know. Let's work it out. 0 less than or equal to 3? Yes, it is. Aren't you excited? So since it's less than or equal to 3, where you see this red dot, you shade that side of your solid green line. Now, I'm going to try to use a different color here, so maybe it'll be more obvious. But look what happens when I shade this side. Okay? And ignore that little black blob up there. Do you notice where the yellow and the fuchsia, or whatever color this is, intersect? It creates a red area. Well, this red area right here are all of the solutions. These are all the values that satisfy this inequality and satisfy this inequality. So when you fill out your paper, you need to make sure that you shade in real dark in this section so your teacher knows that those are all the values and that's the overlap. What I like to do instead is I actually erase stuff and then I fill it in this way. But it's totally up to you. You can just darken it in so your teacher knows what area it is too. It's totally up to you. So right there, all the way up to the line, I just didn't do a good job doing that. Let's fill that in a little bit. All that right there, those are all our solutions. So let's look at part B. Name any 3 points that satisfy the system of inequalities. Well, we can pick anything we want that is in that area right there, that shaded area, or that's on the solid line. Did you forget about that? Those all count too. Those are all solutions. So, I don't know. I can use -4, 0 as a solution. I could use -2, +2 as a solution. I could use 0, -2 as a solution. So what you're seeing here is anything in that darkened area is a solution to the system of inequalities. But let's also not forget that that green line, that solid line, the solid lines count too. They are also a solution. So I could also use any of the points that are on this solid line, such as 0, 3. Okay? You can't use anything on the dashed line though. It's dashed because it's not included as a solution. So do not use any points on the dashed line. All right, with that being said, let's go ahead and take care of part C. -5, 3, is it a solution? So -5, and it's really hard to see on my graph because I kind of went crazy here. So 3, 4, 5. -5, 3 is right up here in this area. And yes, it's in the solid area, so that's good. And then they want us to try -1, no, +1, +1, which is right there. Do you see it? It's on the solid line. If it's on the solid line, then yes, it's a solution. And the last thing they want to know about is 3, -3. So 3, -3 would be right down here. And because that point falls on a dashed line, it's a big no-no. You can't do it. It doesn't count. It's not a solution. It does not satisfy both of those inequalities. Okay. So that's our first big problem. It's like 2 of the first problem put together, right? So let's move on down here. What I'm going to do is I'm going to ask you to graph this inequality and graph this inequality. I want you to pause the video right now, and I want you to do that, okay? 3, 2, 1, pause it. Hey, did you pause it? Please pause it. Now I went ahead and I put both of these lines on the graph, but I haven't filled anything in yet. Did you try your test point of 0, 0 for the blue line? Well, if you did, that's great. I know it's going to work automatically though, because doesn't it fall on a solid line? So let's not use 0, 0 for the blue line. Instead, I don't know, you can use 1, 1. 1, 1 is not on your blue line. So let's go ahead and use that. So if I substitute this in, is 1 less than or equal to 3 times 1? So in other words, is 1 less than or equal to 3? Yes, it is. That's awesome. So we're going to shade that side of our blue line, just like this. Okay, let's tackle this next one. Let's just go ahead and let's just use the exact same point. It's already on our graph anyway. So is 1 greater than -1 plus 5? Or in other words, is 1 greater than a 4? No way! No way! So we're not going to shade that side of the green dashed line. So we don't shade this side, we shade the other side. And what hopefully you can see on your screen is we have this beautiful red area right here. These are all our solutions to the system of inequalities. So either darken that in really well, or if you're like me, you can just go in here and try to color it all in. So it's real noticeable what area is going to be your solution area right there. All right, if you're feeling good, let's keep on going. Move it on down. And remember, at any time, if I'm moving too quickly for you, pause the video. That's what you should be doing. Okay, let's look at B. Now, I'm looking at this, and it is definitely not in slope-intercept form anymore, right? It's in standard form. What's standard form good for? X and Y intercepts. So let's just go ahead and find our X and Y intercepts here. So if we have 0 for X And I'm going to change this into an equal sign since I'm doing intercepts. I'll have negative 8y equals negative 24. And when I divide, I will get 3 for my y-intercept. Let's go ahead and find the x-intercept. So I'll have 6x minus 8 times 0 equals negative 24. And then I'll have 6x equals negative 24. And I get x is negative 4. So there's my x-intercept. You'll notice here that we have a solid line we will be graphing. So just go ahead, go right across there with your x and y-intercept. Isn't that nice? I love standard form. Let's go ahead and talk about a test point while we're at it. So our test point here can be 0, 0 because it is not on the line. And we'll do 6 times 0 minus 8 times 0 greater than or equal to negative 24. We want to know, is this true? Is 0 greater than or equal to negative 24? And yes, sirree, it is. It is greater than negative 24. So where we have our test point right here, we're going to shade that side of the line just like that. All right, so what I'm going to do is I want you to pause this right now, and I want you to graph the next inequality, and I want you to shade, and when I come back, we're going to have the answer on the screen. Don't shortchange yourself. Pause it, try it, see if you understand, and boom, there's the problem. Now you'll notice here, I went ahead and did my x and y-intercepts. Y-intercept at negative 6, x-intercept at 8. I did my test point, and yes, the test point worked. Now I shaded this in pink. So where these two inequalities overlap is this beautiful red area right here. What you're probably noticing here is these are two parallel lines, and the solutions are all the space in between there, all of those points in between. So you know how I am. I've got to go ahead and clean this up, and I'm going to make it more noticeable what our solution set is there. So it's all this space inside here. Okay, so it's a little weird one, right? So let's keep moving. You never know. Some of them are weird. Oh my goodness, now we've got 3 of them, right? No big deal. You can handle this just like you handled the rest. So first thing, let's plot this 7, slope-intercept form, right? Then we're going to go down 7, we're going to go over 8. Now we're kind of off of our graph here if we go any further, so you can go ahead and just dash it now, like that. My arrow's a little funky over there, so let me fix that. Okay, let's try a test point. So 0, 0 is not on our line. So is 0 less than negative 7/8 times 0 plus 7? Well, is 0 less than 7? Sure thing it is. So we're going to go ahead and we're going to shade where this test point is. Just like that. And then the next thing we're going to do is graph these other 2 lines. Now, don't be all freaked out like, oh my gosh, there's no x here. What am I going to do? Guys, it's a horizontal line going right through 1. And it's going to be solid. So we'll go ahead and we'll do our horizontal line right through 1, nice and solid. And then we're going to do the test point again. 0, 0 is not on our line, so we can go ahead and use this, and we're only going to use the y value. Is 0 greater than or equal to 1? No, it's not. So since it's not, we're not going to shade that 0, 0 side. Instead, we're going to shade on and upward. So look what's happening already. Do you see that green area? So far, that's our solution set. But we've got a third little guy over here to take care of. And I know you're really excited about this because it's something different, right? Having 3 inequalities. Don't get freaked out there's not a y here. It's a vertical line going through 2, and this one is going to be dashed, just like this. La, 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 la. Okay? Now we're going to do our test point. Our test point here would be 0, 0 again. You're only going to use the x value. Is 0 greater than 2? No, not at all. So since it's not, we're not going to shade over here. We're going to shade on the other side. Now, a little harder to see here, but do you see it? It's this darkened area right here. It's that beautiful little triangle right here. That's where all of them touch. Okay, we're coming to the end here. I want you to try this last one before you get to class. We expect you to have it done and completed, and we're going to talk about when we get there. Gotta go, guys. See you next time.